Good morning, everybody. First of all, I would like to thank PAGEV and their organizers for giving me the opportunity to present one of the key development programs we have within DuPont company, which is the recycling of plastics, and in this case, recycling of food packaging waste into non-food packaging applications. I would also like to apologize that it's a bit impolite that I will have to twist my head. I will show sometimes my back. The reason is that I expected to have a screen in front of me, and I called a doctor this morning quickly. I went to an hospital before the meeting, and I asked him, could you please do me a surgical operation very quickly to put my eyes behind my head so that I can still face you. In the meantime, I can read my screen. So unfortunately, he said, no, it's too late for you and you are too old anyway. So keep your eyes in front of you. But in this case, I will have to turn my head and sometime I will show my back. I'm sorry for that. So next slide, that's for me. Okay. This presentation, I would like to do it in twofold. One is what we, DuPont, the perception of DuPont regarding the market itself, and what I will share with you today is most what we have done or what we have seen in Western Europe, okay? But after 3 days in your nice country, I can tell you that I didn't see a major difference between what is going on in the Western Europe and what is going on in Turkey. So for the first part, it will be something about market, and the second part will be a little bit more technical regarding what we could do with DuPont as a chemist to improve the quality of recycled polymers. So as a snapshot of the market, this is again the picture what I see in Western Europe. You have the packaging post-consumer waste are today dominated by the bottles. Everywhere, bottles, bottles, bottles. Even the curbside collection, they have been dedicated to bottles. So the bottles are PET and PE, polyethylene and polypropylene bottles. But we also see in Europe a demand and a trend to have more mixed up polymers coming from packaging waste, coming from the curbside collection, and they are not necessarily PET, PE, and PP. Also, we have seen, or we see right now, that there's a wrapping up of recycling of other post-consumer waste, like, for instance, the complex film, the multi-layer films. I heard this morning about the barrier performance of packaging, and in this case, you need, if you have a barrier, you require barrier performance, you need multi-layer structure. But today, what they do in Europe, Western Europe, they burn it, or they landfill. That's what they do. Or they ship to Asia, in China, for instance. So in other words, they don't recycle. They don't do mechanical recycling of these products today. What we have seen is that pops, tubes, and trays are packaging not yet considered, but if you look at the volume they represent, it's a potential additional feedstock for recyclers. Surprisingly, and it was also my surprise, I did not expect that West Europe would export so many waste outside the borders of Europe, and particularly in Asia. But you are aware, and this is something that was what was highly highlighted in the UK, that China has now a green fence policy that they don't want to use anymore very contaminated waste. And that means that the product that used to be shipped in China, now we have to do something with it in the Western Europe. And last question about that, or the fact I have seen and this was well highlighted by my previous speakers, is the fact that they want to reduce post-industrial packaging waste by intensify the in-house recycling at the converters level. Also, the question will be about multi-layer packaging with one layer dedicated to that. So if you have a multi-layer extrusion blow molded container of film, you dedicate one layer to this recycle trim-off. The problem is that not everybody has the right machine and the right die design to do that. Also, down gauging was highlighted. There is a limit for die gauging, which was very well expressed this morning. You cannot do everything with die gauging. The example I like very much is this glass is so thin now that you need three cups to hold the product. So all this is what we learned. This is a little bit old chart, but this gives you the situation. If you go from in Western Europe, 46.4 million tons of plastics, that they go to the waste, 28.8 million tons, and then you divide. You divide by 42% that goes to landfill disposal, and the rest is recovery. So the 57.9 in 2010, more or less is 24% go to mechanical recycling, and the rest goes to energy recovery. So now, what about the trend? I'm not talking anymore about what I've seen, what I have heard, talking to different members of the value chain. There is a strong push in some countries of Europe, but also at the EU in Brussels, to reduce or eliminate completely landfill, which I guess is very good for us and for our children and for grandchildren, etc. There are countries already who ban completely landfill. Germany is an example. Netherlands is an example. No way for landfilling. Incineration without energy recovery will be banned. No way to burn product in the field like that. You risk to pollute. So at least you need energy recovery. But even though with energy recovery, incineration is questionable about what's the risk to pollute the air, for instance. So the major preferred option is the mechanical recycling. Okay? The outcome of that is that if you cannot landfill anymore, if you cannot burn anymore, you will have more waste to recycle. Because even though we try to reduce at the source, at the converters, we are more people in the world. We will be 9 billion people in, I guess, 2040. So we will consume more, so we will generate more waste. So the question is, if you do not accept landfill and incineration, the risk would be that you have more contaminated waste. There is a push to ask the film converters, the companies, the producers of the packaging, to reduce the, to produce less industrial waste. But when you talk to recyclers, they say, oh, we have no problem to find a customer. That's not the problem. The problem we have is to have enough feedstock. But if you reduce the quantity from post-industrial, you don't have enough feedstock anymore. It's a pity because the quality of the post-industrial waste is by far better than the post-consumer waste performance. Okay? Now, there will be also taking into account the more non-bottle post-consumer waste recycling, like pots, tubes, trays, multi-layer containers, and filmed and mixed plastics, which means, as I said already, more contamination or risk of more contamination. At the end of the value chain, you have the end users. And the end users, what they want? They say, we want to consume, we want to use more recycled polymers. Okay, in our product, we want to make our product with more recycled polymers. We need more volume, but no way to get the bad quality. We have certain standards, we have certain specs, we want to meet these specs and make sure that if we make our part in a recycled polymer, it at least equal to what we do with virgin polymers, almost. Okay, so the end users, they want the volume and they want the quality. Again, this is what could we do in general, not just DuPont. Recycling for post-consumer and post-industrial packaging waste. Of course, you can incinerate, provided you give higher efficiency of energy recovery. There are some innovation development work on, let's try to take the waste to make new polymers or the same polymers as originally. That means people are trying to make new polyethylene. There are also some ideas, some work on how can we extract fuel from waste, which is by pyrolysis of plastic waste. Of course, they talk about closed-loop mechanical recycling. An example is, can we do it from food packaging and back to the food packaging? And we have a cradle-to-product mechanical recycling, and that's the purpose of my presentation, which is we start from food packaging, but the waste will be used in non-food packaging. What are the key requirements in this case? Here I try to summarize quickly what is required for food packaging and what is required for non-food packaging. Food packaging, most of the time we talk about food contact approval, the drinking water approval, transparency, particularly in the case of films. The product needs to be clean, no contamination, of course. The organoleptic are important. Appearance, aesthetics. It must be easy to process. But an example is the constant viscosity and the melt strength for extrusion blow moldability. The drawability is important when you make a film or container, and I'm sure you will agree with me. In the non-food application, since they are not the same, very often aesthetics becomes important. Surface finish, colorability. If I want to use a recycled product, to make a car interior part, the car maker will say no odor. And we know that sometimes with recycled waste, we have an odor, or at least it would be a pleasant odor. Dimensional stability is important, particularly for injection molded part. Easy to process is the same story for blow molding, for injection molding. But what is important here is the mechanical strength. They will pay much more attention on tensile strength, elongation at break, flex modulus, but more important and utmost important is the impact strength of the finished product. So the needs are summarized here. The need for recyclers, they need larger quantity of high quality feedstock. Question is, would they be able to find it? And improve the mechanical properties of their recycled polymers in order to get closer and closer to the virgin polymers. So there are different solutions in mind. One is, simple. I segregate, I deny everything which is contaminated. I don't take it, but in this case, you will not have enough feedstock. The other way is, of course, make the process to sort, to wash, to clean the waste more efficient. That means that you need to invest in machines which are state-of-the-art. So the question will be a CapEx issue. Do you have all these recyclers? Do they have the money to invest, particularly in Western Europe when we talk about the economic crisis? And another option, and that's where we work, is to say, okay, let's not try to separate in a way that finally we have a very low percentage of contaminant. Let's take as is, and let's try to boost the properties by using compatibilizers. So the contamination is probably the major cause of a quality recycled polymers. The recycler, we need to keep in mind a product that is recycled has already processed at least once or several times, which means that the product has to be treated in a way that it will be impacted on the viscosity, for instance. That's one of the major issues of the recyclers. But also, if there are contaminants inside, the product will become brittle. And I will explain chemistry-wise why it is the case. Contamination of polymers by other polymers is more frequent and more recurrent than we think, even though at low concentration. And a good example is, for instance, if you ask recyclers, how do you do to separate polyethylene and polypropylene? They say, oh, we have a problem already. It's the same density. So it's difficult for us to do it by flotation. So unless you go at the beginning where you are able to identify this part is in polyprop, this part is in PE, maybe you can do it. But even with infrared sorting machines, with the state-of-the-art machines, it's still difficult because it depends on the size of a particle, the size of a waste, if it's a small one, if it's a big one. If it's a big one, you can sort it easily. If it's a thin one, difficult. What about the multi-layer structure? Much more difficult if you have a multi-layer structure. So here we have the example of PE contaminated with PP or vice versa. An example is, surprisingly, I thought that, okay, this is my PET bottle. I take my closure, which is in polyethylene, separate easily. No, because there is a little ring in polyethylene. So what they try to recuperate it. So what they do, they cut the head or the thread of a bottle, and then they create a dust of PET that will be blended with the polyethylene. A low amount of PET will damage the PE properties. Okay, again, the barrier properties, we absolutely need barrier properties. I heard somebody coming from the EU Commission, he said, the future will be, we use mono material for packaging. Wow, mono material, just only polyethylene. Okay, you know that the barrier properties is a function of or impacted by the thickness of the packaging, okay? So the oxygen absorption. Imagine that you don't have a barrier performance grade like EVOH. What will happen is you make it pure PE, monomaterial, but the thickness of your product will be like a bunker. So forget it, it's unrealistic. Okay, so we have to live with that. So you cannot burn it, you cannot landfill, and now you still need this product. Some people say, okay, we will reduce the contamination level by dilution. So that's what they do. They just mix up again, until the low concentration achieves a certain level. And they guarantee you, they give you a certificate, my product does not contain more than X%, usually it's 5% impurity. Impurity in the case of polyprop is PE, for instance. That's fine, but it requires more time and cost to achieve that level of low concentration. Now, what is a compatibilizer? I'm sorry, I go to a little bit of chemistry. I'll try to make it simple. On the left-hand side, you have a picture, a microscope picture of a polyethylene containing 30% nylon. So you see, there is a pointer here? No. Do I have a pointer? No. Okay, anyway. So you see that you have this bubble and the hole. The bubble is the nylon contaminant, and surrounding is the polyethylene. If you use a compatibilizer, on the right picture, you see that the dispersion is much, much better. Okay? What it means in terms of brittleness or impact strength. If the schematic drawing shows that if you don't have any compatibilizer, you have space between the contaminant in red spot and the rest of the matrix, which is polyethylene in gray. Now, if you use a compatibilizer, you have an extremely good bonding between the two polymers which are incompatible. So if you create a crack, the crack will not propagate and will stop at a certain time. Okay? And that's why compatibilizers are so useful for impact strength. So you have different kinds of compatibilizers. Again, I will not bother you with all this chemistry, but you have polymers. I take example, polymer A and B. You took a compatibilizer based on only the ionic force, ionic bonding. Sometimes it's just a branching effect. Some compatibilizers use maleic anhydride grafted functionality. What means that the matrix of the product is similar to or is the same as the polymer A, but the functional group will react with a branch of a polymer B. That's what we call maleic anhydride grafted polyethylene, polypropylene, and so forth. It could be also GMA. Something that we are developing now to achieve better performance is a combination of different compatibilizers together. Okay. Now, here is an example of the product we have. We have studied already PEPA, PEVOH. The reason why we did that is because we are one of the major supplier of tile layers for the PEPA. You know, if you make PEPA multi-layer, you have no adhesion, you have delamination. Same for PEVOH. So we supply the tile layers, and the chemistry of the tile layers help us to develop compatibilizers. So that's, you see some brands. The last one, which is called compatibilization system, patent pending. This is the dual system I talked about. This is the one for PPP. Okay. Now, that's a good example I like very much. This is from Brazil. What we have here, you start from the top. I'm sorry, I cannot bring the microphone with me, but you start from the top, and you have somebody who will produce a multi-layer bottle and container. At that time, because it's a multi-layer concept, he requires a tile layer with it, and that's where we similar to Fusabon in our brand. Oh, thank you very much. Then the container is filled with the product, in the case of crop protection products, or it could be filled with lubricant oils. Then the product goes to the gas station, where you buy the lubricant oils, and then or it goes to the farmers for the crop protection products. Once this packaging are empty, they go to a recycler. And recycler, with the help of DuPont and an institute in Brazil, we developed recipes in a way that you can, by using compatibilizers, you improve the quality at a level that it can be used now in pipes, rigid or corrugated. And that's what we do. Again, in this case, it's not enough. The quality here, even though you have some tile layer at the beginning, which is chemistry similar, the performance is not enough to get the quality required for the pipes and corrugated tubes. In this case, we also add Fusabon. Excuse me for that. Now, again, it's a little bit more technical. I will go quickly. If you go on the left-hand side, we talk about Gardner impact strength. If I have 0% of Fusabon, 0% of compatibilizer, you see that the joule per meter impact strength is extremely low for a PE containing 30% polyamide. If I go to the right, you see that I achieve a plateau around 9% of Fusabon. At 9%, I multiply by 6 the impact performance. Same story for elongation at break. If I take the PPPA, it's a similar story. If you have no compatibilizer, this is the level of quality you have. If you take Fusabon P353 and you put 5%, immediately you boost the impact strength and the elongation at break. That's something interesting, particularly short-term for the recyclers, because the main issue for recyclers today is what can we do to improve the quality of a blend of PP with P, or vice versa, because they don't know how to separate them. On the left-hand side, we analyze a PP homopolymer with 10% polyethylene. On the right-hand side, PP copolymer with 10%. And you see that this is interesting as well. If you take the two first bars on the left, you have a gray and the black. The gray is a virgin, average virgin performance. The polypropylene plus 10% is the recycled polymer without any compatibilizer. And of course, you see that there is a drop in the mechanical properties, a drop in impact strength. On the other hand, if you use compatibilizers, you see that in our case, in the case of Antira EP, you can even go at the level of a virgin polymer. If you take the copolymer, it's even more obvious. Here you see on the left-hand side the gray and the black. the gray is virgin, the black is the recycled polymer, a significant drop in properties. And that's the problem of the people. We want recycled polymers, but we want the property of a virgin. How do we do that? If you use our product, like 4% and TRIP, here in this case is the famous double system I mentioned to you, which is patented. We can even go beyond the properties of a virgin polymer. Okay, PEPT, same story. You use two kinds, L-Valoy PT Fusabond 226. Even at low concentration, below 1.5%, you see an improvement in the case where PE is contaminated by PET. PEVOH, something interesting. People recycle online, we know that, and they dedicate one layer for that. But what happens once the product is in your yellow bin in the municipalities? You cannot do it online recycling. So here you have to mix up everything. Here you have the problem of the moisture content. That's something recyclers, and that's the reason why the recyclers, they say, well, no, I don't want to use that strange animal. Because if you have some presence of water in the blend, you see that the properties go down drastically. Now, on the blue one, you see that the benefit of another compatibilizer, which is called Fusabond M603, even in presence of water, you are better than without any coupling agent. And if you compare with different maleic anhydride grafted PE, at the same level of water content, at 0.5%, you are still better than 1%. So now I will finish by this summary. Due to the increasing amount of post-consumer waste and the need to use superior quality recyclates, Fusabond, Antirabond, Antira-EP, and L-Valoy are all DuPont brands, effective compatibilizing agents to upgrading the recycling of various polymer composition, mixed and or contaminated. And before I finish, which is here, I would like to also thank my two colleagues of DuPont Turkey who are in this room. They helped me a lot understanding your market. I really invite you to talk to our colleagues, and maybe you can show with your hands. Also, what I would like to say is that DuPont is extremely committed to innovation. We are presenting ourselves as a science company, not just a chemical company. And when we talk about science company, we cannot innovate alone. No way. The world is so fast now, that you need collaboration. We need partnering. And you are our partners. And to demonstrate that, I would invite you to go and contact my colleagues, because we, DuPont, in the world, we set up several innovation centers in Shanghai, in Geneva for Western Europe, in Turkey, and that's what I would like to say. Talk to my colleagues. If you are interested in partnering, a good way to start the discussion about partnering is to show what we are capable to do, and this innovation center is very helpful in this sense. Thank you very much.
Evet, çok teşekkür ediyorum.